Hi, so we are going to go over section 10.2 and 10.3 in this video. And notice I skipped 10.1. I'm going to leave it up to you to just read the text to get this information because a lot of it is just kind of vocabulary and definitions and just and things that you may be familiar with already. Kind of the same main concepts from 10.1 is that we're kind of skipping over is the type 1 and type 2 errors. So I'll leave it up to you to read up on that. So anyways, section 10.2 and 10.3 are hypothesis tests for population proportions and means, respectively. And so I think the best way to go over this, at least in this video, is to just go over an example and then kind of explain my thought process through some examples. So for section 10.2, which we're going to do first, I'm going to go over problem 15 from page 493, or I'm not sure exactly what page this is, but it's section 10.2, and then it's problem number 15 on Lipitor. And so it's under the 10.2 assess your understandings, the exercises. So anyways, it mentions Lipitor. The drug Lipitor is meant to reduce total cholesterol and LDL cholesterol. In clinical trials, 19 out of 863 patients taking 10 milligrams of Lipitor daily complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking competing drugs complain of flu-like symptoms. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect at the alpha equals 0.01 level of significance? So I just read the problem, and we can see that that there's a lot of information that's kind of standard on hypothesis testing problems that we're going to be pulling out and using throughout the problem. So first off, in any one of these problems, we should have sample data. And with hypothesis testing for population proportions, we should have the Rx. We should have all the information for p hat. So section 10.2 example. So this is number 15 on Lipitor. Yeah, I spelled it right. So anyways, we should have the information on p hat. So we should be given our sample data. Our sample data for population proportion is p hat. That's all the information that we should be able to get from proportion. So what we see is we have X, the amount of successes, or what we consider, I guess, success, out of our total sample size N, which is 19 out of 863. So that I'm just pulling out information. I'm not exactly going through the hypothesis test at the moment, but okay. So anyways, and then there's information. I'm just pulling out the number stuff first. We also have 1.9%, and give you a second to think about what that means. Okay, so 1.9% if in this problem represents P naught. If you don't remember what P naught is, you can look at some examples, but it has to do with the claimed proportion. And in this case, 1.9% is 0.019, 1.9%. So so that represents the claimed value, which belongs in the null and alternative hypothesis. So you may have an idea of where this goes already. I'm just pulling out the information, as we can see. And the only other number that's kind of standard in this type of problem is is the alpha. Alpha equals 0.01 in this case. Our level of significance, and we'll see where this comes into play. So let's go through the steps of a hypothesis test using this information. And so in the text, which should be a few pages back, let's see here. It is on 1, 2, 3, the 4th page of section 10.2, testing hypothesis regarding a population proportion P. So we have these steps that we can go through. This is a good reference on the, I think I said the 4th page of section 10.2 in the purple section, where it says testing hypothesis regarding a population proportion P. There's 5 steps that we go through, and notice that there's 3 bullet points that belong that they talk about before they start the first step, and these are the requirements to do the hypothesis testing. And so the first being, so I'll just call these checks. So the first check, it says the sample is obtained by simple random sampling or the data result from a randomized experiment. And based off of what's mentioned in this problem, when I read this problem, it really didn't say anything about the randomness of the sampling, but if it doesn't say like how they did the sampling, we can just assume that they have a random sampling. So you can just say assume, if it doesn't mention anything about it, assume a simple random sampling. Check. We got that one done. Okay, so we're doing our checks right now. There's the first check. And now the second check, it mentions n p naught times 1 minus p naught is greater than or equal to 10. Now, this should be familiar to you from section or chapter 8, where we need a large enough sample size to have a normal distribution for the sampling distribution. So as you can see, we're using this again. And this should make sense. Well, notice that in chapter 8, we used P naught for this. Or I mean, we used P. And in this section, we're using P naught. The reason we're using P naught is we're assuming P naught, that the claimed value is true. We're assuming that this is true for the time being. So we're using this as you'll see in a little bit where this comes into play again. But so since we're assuming that to be true, we're using that P naught value in our check to see if we have a large enough sample size. So to do this check, we would need to plug in our values. So our n is 863. Our P naught is 0.019, and then 1 minus 0.019. So we calculate this. I'll do that really quickly. 863 times 0.019 times 1 minus, I'm going to put parentheses around this, 0.019, and I obtain 16.09. So is that good enough? So as we can see, 16.09 is greater than or equal to 10. Great. Check. We have a large enough sample size to obtain a normal distribution with the assumed p-naught value. So we're good. So we can assume that we have a normal sampling distribution based off of this size, this value of n, our sample size. So the last check is the sample values are independent of each other. So there's no reason to assume that they are dependent on each other. But the idea to think about this, hold on one moment.